NASA STEM Engagement and Educator Professional Development Collaborative logo. Welcome to NASA STEM EPDC Quick Bits Science and Engineering Practices. NASA STEM Engagement and Educator Professional Development Collaborative provides NASA resources and STEM strategies for STEM engagement. In this series, we intend to reach educators, parents, and caregivers to quickly explain a specific big idea in STEM. We will introduce a NASA example of how this idea is applied in the real world, and finally, we will demonstrate step-by-step how to lead this activity at home or in the classroom with your students. You might invite your students to watch with you at that time. We invite you to join us as we learn more from our specialists. Let's get started.
I'm Sara Torres, NASA Education Specialist at Ames Research Center in California. I will be narrating this quick bit created by Monica Uribe, NASA Education Specialist at Armstrong Flight Research Center in California. The title of this activity is 3, 2, 1, Takeoff. This quick bit's big idea is to present science and engineering practices in data analysis and interpretation. In this activity, the student will be involved in the following practices. From kindergarten to second grade, analyzing data is based on previous experiences and generates the attention, registration, and report of their observations. That is to say, registering the information, observations, thoughts, and ideas. Using the observations to describe tendencies and/or relationships in the real world and in the design world in order to answer scientific questions and to solve problems. Comparing predictions based on previous experiences with what happened, observable events, and analyzing the data from the test, performed to an object or tool as to determine if it works as expected. From 3rd to 5th grade, the data analysis is based on the experiences from previous grades and generates the introduction of quantitative approaches to data collection and the performing of multiple qualitative observation tests. That is to say, representing data in tables and/or in different types of graphics in order to show the specified tendencies among the studied variables, using logical reasoning, math, and/or computer tools to analyze and interpret data, so as to understand the phenomenon and analyze the data to evaluate and improve the design of an object. Aeronaut X is one of NASA's next-gen STEM programs. It focuses on the research and technological developments in aeronautics that have served as small steps and have been an important part of many significant NASA accomplishments, known as giant leaps. Aeronaut X focuses on the latest in aeronautics and the principles of sound, especially on research to create new generations of experimental aircraft called Xplanes. In this activity, we will focus on the creation of a paper airplane that represents the X-59, one of NASA's Xplanes that demonstrates silent supersonic technologies. This X-plane is being built, and once completed, NASA will use it to conduct research on the reduction of the sonic boom produced by this supersonic flight. We will focus on the activity called 3, 2, 1, Takeoff, simple version. One of the main objectives of this activity is to show the 4 forces acting on an airplane. That is to say, weight, lift, thrust, and drag, and to emphasize the fact that each of these forces has an opposing force or pair force. That is to say, weight is opposite to lift is opposite to weight, drag is opposite to thrust, and thrust is opposite to drag. And that when the 4 forces are balanced, the airplane is leveled. Thrust is a force that moves an aircraft in the direction of the motion. It is created with a propeller, jet engine, or rocket. Air is pulled in and then pushed out in an opposite direction. Drag is the force that acts opposite to the direction of motion. It tends to slow an object. Drag is caused by friction and differences in air pressure. Weight is the force caused by gravity. Lift is the force that holds an airplane in the air. The wings create most of the lift used by airplanes. Another main objective of this activity is to demonstrate Newton's third law, or law of motion, which states that for each action there's a corresponding reaction of the same magnitude, but in opposite direction. For example, if object A exerts a force on object B, then object B must exert a force of equal magnitude in the opposite direction of object A. That's an action-reaction force. Let's watch the following video. where NASA's astronaut Mark Vande Hei demonstrates Newton's third law from the International Space Station.
Welcome to the International Space Station. I'm NASA astronaut Mark Vande Hei. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time. A force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Got a basketball right here. It's going to be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied according to Newton's third law by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force. You saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use two similarly massed objects. Joe and I have about the same mass. So Joe, get into a ball. I'll do the same. I'm going to face you this way so that I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him. Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth. See you next time.
Demonstrations. Remember that when we carry out scientific research, information that needs to be analyzed with the purpose of obtaining a result is generated. For this, scientists and engineers use data analysis and interpretation, and tools such as tables, graphics, and statistical analysis. Now, I invite you to perform the activity 3, 2, 1, take off. You can ask an adult to help you. You will need the guide to the activity 3, 2, 1, take off, simple version. The materials to be used are the plain template, adhesive tape, scissors, measuring tape, and straws. We will be using the Xplanes template. If you don't have a printer at home, I'll show you how to make your own template. We'll cut out a section of the template and we will fold it on the continuous line. Then, using adhesive tape, we'll seal the upper section of the longer section of the model. Once sealed, we'll fold the upper part in four, sealing this part with an adhesive tape piece and making sure the entire model is sealed. Lastly, we will have to make sure that the straw enters freely and the model will be ready. It is recommended to have a target. I created mine with the lid of a cardboard box and the lids of some cooking pots. If you don't have a printer at home, you can create your own template. We'll mark the piece of paper every 4 centimeters, and we do the same with the lower part of the sheet. We join and mark 15 centimeters and a half from the top to the bottom on both sides. We join and cut, and we use one of these parts to make our plane. We fold our rectangle to form the paper plane, and we can draw the X59 on it. Engineering research includes the analysis of data collected during the design flights. This allows us to compare the different solutions found, so we will be able to select the best design of a model that would match our specifications. Using the measuring tape, write down the information you obtained about the distances that each of your 3 flights covered, and some observations such as if you need to blow harder, or if you failed to seal the plane with enough tape, or if your flight has leveled or not. To sum up the activity, you can use the discussion questions and analyze how important it is for NASA's engineers to consider the 4 forces that affect flights and Newton's third law when designing an airplane. Once you've completed the 3 flights, you can extend the activity by changing the airplane sizes or its construction material.
Thanks for watching this NASA STEM EPDC Quick Bit. Don't forget to check out the description below for more information and links. www.txstate-epdc.net. Logos for the Texas State University LBJ Institute for STEM Education and Research, NASA STEM Engagement and Educator Professional Development Collaborative, and NASA Partner. The material contained in this document is based upon work supported by a National Aeronautics and Space Administration, NASA, grant, or cooperative agreement. Any opinions, findings, conclusions, or recommendations expressed in this material are those of the author and do not necessarily reflect the views of NASA. Images and footage courtesy of NASA. Images and footage used under licenses from Shutterstock.com and Envato.